You know that feeling when you've been sitting in one position for too long, and when you try and stand up, your foot has gone numb or it starts to tingle uncomfortably? Imagine that this happens to you for the majority of your day. This is one of the most common side effects of something called chemotherapy-induced peripheral neuropathy, or CIPN for short. Now, raise your hand if you know someone in your life who has been diagnosed with cancer. And with that, globally, close to 60% of new cancer cases require some type of treatment, and of those patients, 40% of them experience the side effects of pain, numbness, and tingling, all of which are associated with balance skills, motor skills, and fine coordination skills. There's currently no treatment or therapy that can cure CIPN, and we want to know if there's somehow a way we can prevent this from happening in the future. Previous research has actually shown that in a warm molecule, as pictured here, if we remove a certain molecule, it can actually protect against the side effects of CIPN. In the Wilkinson Neurophysiology lab, we replicated this very same experiment by removing that very same molecule, but in a mouse instead. We mimicked the typical chemotherapy treatments that real-life patients undergo on the mouse that had that molecule removed and a regular mouse over the course of 2 weeks. After this, we looked at how the muscle spindle afferents responded to our lab's electrophysiology experiments. And why did we look at the muscle spindle afferents? It's because the muscle spindles are found in our muscles. They act as these tiny little sensors that send messages to our brain, and our brain is able to interpret this and lets us know how our muscles are stretching or where they are in space. The muscle spindle afferents provide us great information on things like balance and coordination, both of which are affected by CIPN and good indicators of this side effect. We've already found promising results that the removal of this molecule can help protect against the side effects of CIPN in a mouse model. This is one of the first steps in helping to create a therapeutic drug that can act as an inhibitor of this molecule and can be taken in conjunction with treatment. We hope in the future to continue to find solutions that not only target cancer cells, but also improve the quality of care of patients and their loved ones. I wanted to thank the Wilkinson Neurophysiology Lab, Dr. Wilkinson, as well as the chemotherapy team, and also Dr. Miriam Goodman over at Stanford University for everything they've done on this project. Thank you.
Nice, that was a terrific job. Yeah, just first thoughts. Like chemotherapy, obviously, there's lots of challenges that come with that. So just amazing that you're trying to figure out how to lessen the load a little bit by reducing the side effects. Curious as to how you got into this field.
Yeah, definitely. I was always interested in physiology, and when I had the opportunity to talk to Dr. Wilkinson about her neurophysiology lab, I definitely knew that was something I would want to be a part of. And also in my personal life, my own mother was diagnosed with cancer and also went through chemotherapy and experienced some of the things that I was talking about in my speech. So a project that definitely hits close to home for me personally.
Nice. Yeah, it's always inspiring when someone can take a personal problem and use that as motivation to help other people. And then, is this a field you hope to go into in the future?
So for cancer research, it's not what I'm doing presently in the future, but I am going into the field of biotechnology and working in the biotech industry after I graduate.
Nice, that's very exciting. Everyone give her one more round of applause.
Thank you.